Lab 1, Charged Tapes. The objectives of this lab were to produce two separate pieces of clear charged tape, analyze the interactions between the pieces of tape and different objects, find the excess charge on one of the pieces of charged tape, and use a Python program to visualize the interactions happening. The findings from this lab were that the charged piece of clear tape had a net positive charge, and the charge on that tape was 1.1 times 10 to the negative 8th coulombs, and the tape is 6.94 times 10 to the 10th electrons away from being neutral. Concepts used in this lab are Newton's second law, the net force equation, as seen there, and the velocity update formula, which is derived from the net force equation, as well as gravitational force, which is the force that an object feels due to the gravity of Earth, which is mg in the negative y direction. Also, we use the electric force formula to calculate the force felt by one charge, or the force felt by two charges. As you see, the magnitude of the electric force is just the same, except magnitude of the charges, as well as we're basically getting rid of that unit vector. You can see how the U-tape was created by placing an angled piece of tape on another base tape and charging it. Interaction between two U-tapes were that they repelled. Interaction between U-tape and hand were that it attracted. And interaction between U-tape and pen was that it attracted. This is because due to being rubbed with cloth, the pen is negatively charged, since the act of rubbing the pen with a cloth strips electrons away from the clothing onto the pen surface. This means that the U-tape is positively charged, since it's attracted to the pen. Interaction between the suspended U-tape and held U-tape was that they repel, and you can see this setup here on the top right. Separation distance that was measured was 0.025 meters. This is equal to the magnitude of vector r. Here you can see the length of the tape and the width of the tape that was recorded. We use this to calculate the surface area of the tape, and we used this information to calculate the number of atoms. I did this by dividing the surface area of the tape divided by the surface area of an atom. And I got 3.4 times 10 to the 17th atoms. As stated before, the vertical distance between the two U-tapes was 0.025 meters, and the tape weight was 0.0018 newtons. Did this by calculating the mass of the tape and then just multiplied by 9.8. Means that the force of gravity on the U-tape is negative 0.0018 newtons. And the way that I found the charge of the U-tape was by setting Fg plus Fe equal to 0, and then using the force of the electric force equation, set that equal to negative Fg, and since Q1 and Q2 are equal to each other, we just did a square root of all that to isolate Q, and we got that to be 1.1 times 10 to the negative 8th coulombs. Number of deficient electrons, you can see there I divided that charge by 1.6 times 10 to the negative 19th, which is just the charge of an electron, or the magnitude of a charge of an electron. Got that to be 6.9 times 10 to the 10 electrons, and then just set up a ratio to find deficient electrons to atoms, divided that, and got 4.9 times 10 to the 6th atoms. This slide here shows the computational model. On the left we have the constants, and on the right we have the equations for gravitational force. These are the equations that we are going to be converting into code. This section of the code is the calculation and visualization portion. We're going to be calculating the charge of the tape, the number of deficient electrons, and the number of total atoms on the tape, and we're going to be using that to make the ratio as stated before. So that's what all this is. This is the results that the code produces. There is an electron deficiency on the tape, meaning that it is positively charged. The net force acting on the suspended U-tape is 0, allowing it to float. This means that we are at static equilibrium, which means that the magnitude of the electric force produced from the held U-tape is equal in magnitude to the gravitational force felt by the suspended U-tape. Sources of error were that the wrong separation distance measurement, wrong length and width of tape measurement, the held U-tape wasn't in the correct spot, leading to an unreliable separation distance, and of course rounding errors. If protons and electrons switch charges, the direction of the electrical field produced by the tapes would change directions, but the observations wouldn't. since they still would be repelling each other, because like repels like. It's important to handle the charged tapes as little as possible so they don't lose their charge by the electrons dispersing throughout our hands. This would give the negatively charged pieces of tape a more positive overall charge.